Hey math fans, test 8, lesson 6, last one for test 8. Get your swords ready and let's go. So today we're going to draw shapes with a given perimeter and area. We're going to make models to represent mixed numbers, and we're going to find the difference between negative numbers. Let's start by drawing shapes with a given perimeter and area. So my first question asks me to draw a square with a perimeter of 12 centimeters. If I had a ruler, I could measure it out. I'm just going to do a model, which means it's not going to be exactly 12 centimeters, but I'm going to do it to represent 12 centimeters. Because it's a square, I know that it's going to be, each side will be an equal length. It's a regular polygon. So to find out how long each side should be, I'm going to do 12 divided by 4, which gives me 3. Each side of my square is going to have to be 3 centimeters. Again, if I wanted to, I could get a ruler and measure 3 centimeters to make squares. I'm just going to do a model. So that square obviously is not 3 centimeters, but I'm going to pretend it is. And then I will put symbols on to show that all of the sides are the same length. The next one's a little trickier. It asks me to draw a rectangle with an area of 20 centimeters squared. The trick here is to remember the formula for area. Area equals length times width. So if area is 20, then I have to sub in any two numbers that will multiply to give me 20. For example, 4 and 5. That would work. 2 and 10 would also work. 1 and 20 would work. But for my purposes, I'm just going to do 4 and 5. And again, I'm going to do a model. I'm not going to pull out my ruler for this. So there is my rectangle. And I'm going to say, obviously, that the shorter side is 4 centimeters. And the longer side is 5 centimeters. And I'm going to use some symbols to show that these sides are the same length. So now here's a bit of a challenge for me. I'm asked to draw a rectangle with a perimeter of 30 centimeters and the smallest possible area. So what I'm going to do here, I'm going to remember that area is length times width. I don't know the area. The perimeter is 30 centimeters. Now right now I don't know the area. I do know the perimeter, which is 30, but remember that the perimeter is all 4 sides added up, whereas area only uses 2 of the sides. So what I want to do is find out what these sides could be to give me the smallest possible area. If the perimeter is 30 centimeters, that means that these two together are 15 centimeters. Okay? That's because I did all 4 sides. So 2 sides will be half of that. So the area is going to be the length times the width, and the length plus the width have to equal 15. So all the numbers that could add up to 15 would be 1 and 14, 2 and 13, 3 and 12, 4 and 11, and so on. So what I want to do, this question is asking me to find the smallest possible area. I need to find out which of these combinations that I've come up with will give me the smallest area. So area is length times width, so 1 times 14 is 14. 2 times 13 is 26. 3 times 12 is 36. 4 times 11 is 44. So you're probably seeing a pattern right now. If I want the smallest possible area, I probably don't want to keep getting bigger. 1 times 14 is probably going to be my best bet. So now that I know that, I can draw my rectangle. And it's going to be really skinny because my length will be 14 centimeters and my width will be 1 centimeter. So hopefully that makes sense. To get the smallest possible area, I just needed to take my perimeter, which was 30, realize that the length and width of 1/2 of it would be 15, then find all the numbers that could add up to 15 and try multiplying them to see which gave me the smallest possible area. Next, let's talk about using models to represent mixed numbers. So here we have Grace, and Grace is making some quilt squares, and it says that she needs to use half of a red square of fabric to make all the red triangles in one patch. So we want to know how many large squares of fabric she needs to make 5 patches. So Grace says if I use half of a square for 1 quilt patch, I need 5 halves for 5 quilt patches. That's more than 2 red squares, but less than 3. So we know that every time she wants to make one quilt square, she's going to use half of a fabric patch. So since we know that, we can just follow along with her. She said 5 halves equals 2 halves plus 2 halves plus 1 half. 2 plus 2 plus 1 is 5. So she knows 2 out of 2 is 1. So 5 out of 2, which is what we're doing 5 halves, is going to equal 1 plus 1 plus 2. And that's because my 5 halves is the same as 2 halves plus 2 halves plus 1 half. So the mixed number, 5 halves, the mixed number 2 and a half is the same as the improper fraction 5 halves. 5 out of 2 is the same as 2 out of 2 plus 2 out of 2 plus 1 out of 2. These are both equivalent to 1, so 1 plus 1 is 2, 2 and a half. She needs 2 and a half large squares of red fabric to make 5-star quilt patches. And she knows that her answer is reasonable because 2 and a half is between 2 and 3. So let's see if we can do it. It says model 17/4 as a mixed number. So I have to decide how many fourths are going to be in 17/4. So 4 plus 4 would give me 8. That's not enough. Plus 4 would give me 12. That's not enough. Plus 4 would give me 16. Plus 1 would give me 17. And all of these, of course, are actually fourths. Now, all of those 4 fourths are the same as 1. So it's actually 1 plus 1 plus 1 plus 1 plus 1 fourth, which would be 1, 2, 3, 4, and 4, a quarter. However, it didn't ask me to write down what it would be. It asked me to model it. So I'm going to draw 4 squares and a quarter of another one. And there you go. I have 1, 2, 3, 4 full pieces and a quarter of another piece. So now you give it a try and model 11/8 as a mixed number. Just pause here and do a quick sketch, see how you do, and when you come back I'll have the answer for you. So here's your answer. 8 tells me that there's 8 pieces in the whole, let's say it's a chocolate bar, and 11 of them are colored in. So that's 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3 extras colored in. If I take out my pieces, then I will have 1 3/8, and that is the mixed number. 1 whole is colored in, and 1, 2, 3/8 are left over. And finally, we're going to find the difference between negative integers. So here we have, Leah did a report on climate change in Canada, and she included a chart showing typical temperatures in the capital cities of the Western Provinces and Northern Territories. So here's her list. And you can see she's got the low temperatures here and the high temperatures here. And we want to know what is the order of the temperatures from the coldest to the warmest. So Leah here has made a number line. And she said, my number line looks like a thermometer placed on its side. She marked 0, which is freezing. And the low temperature, the lowest temperature on my whole list is -31 in Yellowknife and Iqaluit. And so she marked that. And then she's going to mark the other temperatures on her list, and that will give her the order of the temperatures. So her finished list would look like this. So that's what my list would look like, and then when I put them in order, and there's my list. And you can see it's much easier to do that when I put it in order on a number line than when I just try to look at the chart. So this next question asks me, what is the difference between the highest and lowest temperatures? So as I discovered on the other chart, the lowest temperature was -31, and the highest temperature is +7. So I need to know the difference between -31 and +7, and there are 2 different ways I can figure that out. So on this number line, I'm going to mark the lowest temperature, -31, and the highest temperature, which was there's 10, 9, 8, 7. So to find the difference between them means I'm going to count up how much space is between them. So this is the first way I can do it. I can just count up the spaces. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. So the difference is 38 degrees. Now I'm sure you have already spotted the flaw in this method, which is that it requires me first of all to draw a number line and then to sit there and count every single little dot. So there is actually a much faster way to do this. All I have to do is, because I'm using a negative number and a positive number, I'm just going to look at the difference here. So what's the difference between 7 and 0? There's going to be 7. And then going this way, what's the difference between minus 31 and 0? It's going to be 31. And then when I put those together, they make 38. So that's all I have to do to find the difference between those two numbers. And we're done. So, review. First of all, draw a rectangle with a perimeter of 20 centimeters and the smallest possible area. You do not have to use a ruler, just make a model. Number 2, draw a model for the mixed number 2 3/4. And number 3, if the temperature yesterday was 8 degrees Celsius and today it is minus 12, how many degrees did the temperature drop overnight? That's it. Have a great night, and I'll see you in the morning.